Kubernetes has become the de facto standard to deploy and operate applications in containers. Not only the Kubernetes Community Edition, but also other Kubernetes-based distributions are increasingly used in both public and private clouds. GKE, AKS, EKS, ROX, OpenShift, Tanzu, Rancher. These are only a few examples of the great adoption that the Kubernetes engine has had over the last few years. Installing Kubernetes is a straightforward process. However, it can be a bit overwhelming for those folks that are just starting their cloud-native journey. Do you want to learn how to deploy a Kubernetes cluster in less than 10 minutes? Then, let's get started. Today we want to show you how to install Kubernetes following a few simple steps. Nowadays, there are tons of Kubernetes services available in almost any cloud provider. But this is a quite simple process. You only need to go to your cloud provider, select any of the Kubernetes service that you want to deploy, click on install, and in a few minutes it will be up and running for you. In this use case, we will show you how to install Kubernetes Community Edition by deploying a 3-node cluster. First, we will deploy Kubernetes in a single node. Then, we will proceed with installing and joining the other 2 control planes to our cluster. There are several ways to install Kubernetes. If you take a look at the official documentation, you will find up to 3 different ways to install Kubernetes. Those are kubeadm, kops, and kubespray. Let's talk a bit about these 3 different tools. First, we have kubeadm. kubeadm is a tool that was built for bootstrapping Kubernetes nodes, but this tool doesn't take care about the underlying infrastructure. Second, we have kops. Kops is a tool that was built for deploying Kubernetes from the command line interface. This tool takes care about the underlying infrastructure in the cloud. And third, we have kubespray. Kubespray is a tool that can deploy on both public clouds and bare metal infrastructures. For deploying and orchestration, it uses Ansible under the hood. This time, we will use kubeadm to install Kubernetes. The reason behind this is just because we have a few virtual machines handy and we want to use this existing infrastructure for this activity. That way, you will see the process in a transparent way, avoiding these extra automation and orchestration layers like could be Ansible. Just before starting, I would like to bring up a few things that you need to take into account. At the installation time, when deploying Kubernetes on the first control plane, you need to provide a few parameters to the kubeadm command. You can either provide these parameters on the CLI to the kubeadm command, or you can create your own config file and put all your customizations in that YAML file. We will go with the second approach. That means that we will create our own config YAML file. The reason behind this is just because we want to configure the kubelet cgroup driver. And this is something that it can be done only by creating a config YAML file. And you may be wondering, why should I take care about the kubelet cgroup driver? Let's talk about this. So when using systemd init-based operating systems, like in our case where we are going to use CentOS Stream, it is highly recommended to configure the kubelet with the appropriate kubelet cgroup driver. In this case, it should be the systemd cgroup driver. And that's basically because we want to avoid having multiple cgroup drivers running on the same operating system. In our case, we are going to use CentOS Stream, so it makes a lot of sense to change the kubelet cgroup driver. As you will see, I will add a few other configurations to the config YAML file, like the pod network and the control plane endpoint parameter. The first one is the pod network. This parameter lets us configure the pod network address that will be using our pods in our cluster. In most of the cases, the default configuration is going to be okay for you. But if you want to configure and put your own network address for your pods, this is the time. Put the configuration in the config YAML file and it will be applied. The control plane endpoint parameter is key when deploying multi-node Kubernetes clusters. This parameter holds either the IP or the DNS and the port of the load balancer supporting the Kube API service. This parameter is super critical, because if you point this parameter to a single node, you will be losing the high availability of the Kube API service, and this service is a critical service for the Kubernetes cluster. At the installation time, we will do a little trick. Initially, we will deploy the Kubernetes cluster with a single node. So the control plane endpoint parameter will hold an external load balancer name, which eventually will be used for our external load balancer. At this moment, there is no external load balancer. So we are going to point this DNS, the one that will be used for the external load balancer, pointing to our first control plane node. And why we want to do that? It's simple, because at this moment we are installing only a single node cluster. Next, we will be joining two other control planes to our cluster. When installing our first control plane, we can use an external load balancer name, which eventually will point to an external load balancer, but at this moment, this name will only point to our first control plane. That way, we are sure that the installation is going to run smoothly in only our one single node. As soon as the installation is finished, you will see that we will go to the HA proxy and we will reconfigure the HA proxy. We will enable both control plane number 2 and control plane number 3 to start accepting and serving requests for the API service. Let's start with checking a few things on our infrastructure. In this use case, we are going to use a CentOS Stream Release 8, and for nothing in particular, but just because we had this image handy. In terms of resources, if we see the memory, we already assigned 16 gigs, and as we will see here next, we already assigned 8 virtual CPUs. When it comes to the network interfaces, it's worth checking the product ID, just because we want to be sure that all the IDs are different across the nodes in our cluster, just to avoid collisions. This will be eventually a 3-node cluster, so just before starting with the installation, we want to be sure that we have full connectivity across all the members in the cluster, so we can see it just running a ping to ensure that everything works as expected. Before installing the container runtime interface, there are a few requisites that need to be met. Overlay and VRNet filter kernel modules need to be enabled. In addition, some kernel parameters need to be configured via sysctl commands. That way, we enable IP forwarding and we let IP tables see the bridge traffic. After doing these last changes, let's ensure that these changes have been already applied to the system by running a few commands like sysctl and lsmode. One of the last configs we have to do before starting with the installation is to disable swap. This is a requisite from the Kubernetes installation and is just to avoid issues with the kubelet. So you only need to run swap off to disable swap, go to the fstab file and comment out the corresponding line. Let's get started with the installation process. First of all, you need to deploy the container runtime interface. In our case, we choose CRI-O. If you follow the official instructions, you will see that first of all you need to export a few variables. Versions is the version that you want to use for CRI-O, and OS is the version of your operating system. In our case, is CentOS OS 8 Stream. Then we download the repositories where the packages are available, and then we run the CRI-O installation. Be patient, this can take a few minutes. As soon as CRI-O is installed, enable and start the service. Let's continue with installing kubeadm, kubectl, and the kubelet. Before deploying this software, we need to set Linux in the permissive mode. This is a requisite from the Kubernetes installation, just to allow containers to access the host file system, like for example, some cluster network plugins that might require that. So we are good to go. We add the Kubernetes repository 1.29, which is the latest version as of today, February 2024. use dnf or yum to deploy the kubelet, the kubectl command, and the kubeadm binary. As a last step, enable the kubelet service, but keep in mind that this service will remain in a kind of a crashed loop backoff state. That's because the kubelet is waiting for instructions from the kubeadm command. Now let's comment out the load balancer name in the host file, and we will point the load balancer name to the first control node in the cluster. We do this for the sake of simplicity. That way we can use a load balancer DNS name but pointing to the first control plane. In the future, we can change this DNS name to point a real load balancer and expand the cluster with additional nodes. Now it's time to run the Kubernetes installation. We use kubeadm binary. When using kubeadm, you can either choose to pass a few parameters on the command line or run the installation using a kubeadm config file. We choose the latter for a good reason. For those distributions that leverages systemd as the init system, it is highly recommended to configure the kubelet with the systemd cgroup driver. By doing this, we ensure that we are aligned with the operating system expectations, leveraging a single cgroup manager. In a very short time, you will have your first control plane up and running. As soon as the installation is finished, be sure that you keep safe, especially the kubeadm join information. You will need that data if you want to expand by adding a new control planes to your cluster. In addition, follow the instructions to start log into your cluster by just simply copying the admin config file or exporting the kubeconfig variable. Once you are in, you can check that we actually have a few pods running in our cluster by running the kubectl getpods command. We already deployed our Kubernetes cluster with a single node, but that's not all. We still need to deploy the container network interface. The CNI is required in a Kubernetes cluster to allow connectivity between pods. There are a lot of CNIs available for Kubernetes. In the Kubernetes documentation, you will see a huge list of CNIs available for your Kubernetes cluster. In our case, we decided to go with Calico. One of the requisites is to configure Network Manager properly. That's because Network Manager manipulates the routing table for a host. So creating this Network Manager configuration, we prevent from Network Manager interfering with Calico interfaces. Now we can go with the Tigera operator installation. Just run the kubectl create command, pointing to the Tigera operator YAML configuration file, and in a few seconds you will see the Tigera operator pod running in your cluster. This operator provides the framework required to deploy the CNI plugin. You can deploy Calico by either running the kubectl command or just deploying the YAML definition if you want to customize the Calico installation. In our case, we go with the latter, since we define a customized pod network configuration at the installation time. If you did the same, then edit the configuration file, set up your own pod network configuration, and run the installation by running the kubectl create command with the YAML config file. Wait for a few minutes and you will see how your Calico pods are up and running. The final step is about removing the taint on your control node. You only have a single control plane node running on this cluster, so if you want to run your own workloads, you will need to do that. As you already saw, we managed to have our first Kubernetes cluster running in less than 10 minutes. So that means that you now can start deploying your applications and services. But remember, this is a single node cluster. That means that if you have any issue with your node, your applications will not be available anymore. Let's expand our Kubernetes cluster by adding 2 additional nodes. You already have the experience of deploying Kubernetes on your single node, So you will soon realize that this is more or less the same process, but this time we will use a slightly different kubeadm command. So let's see in detail. As we said earlier, we need a load balancer in place to balance the request to the Kube API service. So we have deployed a new virtual machine which runs an HA proxy. This is how we configure the HA proxy, but basically we set up 3 frontends and 3 backends. That's because we want to balance both HTTP and HTTPS traffic for our applications, and naturally for the Kube API service. Take a look at the Kube API service backend, which is forwarding traffic only to our first control plane. That's because the other 2 are not part of the cluster yet, so they couldn't handle these requests. First of all, let's go to the first control plane and let's be sure that the DNS name that we use for the load balancer actually points to the load balancer. As you saw earlier, the HA proxy is just forwarding traffic only to the first control plane, but for now this is okay. Before deploying Kubernetes on the other 2 control plane nodes, you need to copy the control plane certificates to the new nodes that are going to join the cluster. If you go to the Kubernetes official documentation, you will find information about this process. But basically, it is about copying a few certificates that are required to join the cluster and give the appropriate permissions on every node. You have to be sure that these certificates are in the right place on the 2 nodes that you want to add to the cluster. You can skip this manual process by providing the upload search when you deploy the first control plane with kubeadm init. By doing that, the Kubernetes certificates distribution is automated. So we already have our Kubernetes certificates on both nodes. So it's time to go to the first control plane and get the kubeadm join command that we need to run in both control plane nodes. So we can do that by inspecting the output from our kubeadm init installation in our first control plane. Run the command as it is in the output that we got when we install the first control plane and wait for a few minutes. As soon as the kubeadm join command is finished, you can export the kubeconfig file. This is one of the easiest ways to get access to our Kubernetes cluster. You already logged into our cluster, so you can now run kubectl, for example, kubectl get nodes, and you will get the information about the nodes in our cluster. As you can see here, the number 2 is the new node that we recently added to our cluster. If you run kubectl get pods, you will get all the pods running in our cluster. So it's time to join the third control plane. So basically, we need to do the same. First of all, go to the first control plane, get the kubeadm join command that we need to run, go to the third control plane, and start adding this new third control plane to our Kubernetes cluster. Wait for a few minutes, and that's all. Let's do the same that we did a few minutes ago. So as soon as the kubeadm join command is finished, you can get access to your cluster by exporting the kubeconfig file. So you can get information about the pods and the nodes that are part of this Kubernetes cluster. And as you can see here, we already have our 3 control planes in our cluster. So as soon as we are sure that every node has its own Kube API service running properly, we need to go to the HA proxy, edit the configuration, and enable the 3 nodes for this HA proxy service. That way, any single request to the API service on this Kubernetes cluster from now on will be load balanced over the 3 control planes in this Kubernetes cluster. After the last changes, the only thing we need to do is to restart the HA proxy. That way we apply our last changes in the Kube API service. And before wrapping up, let's check that all our pods and nodes are ready and available. If you like it, click on like. And if you wanna see what's coming next, don't forget to subscribe. So that's all. See you next time. Cheers!